Hey guys. All right, today we are going to be working on what we call function tables. Function tables. They're basically the same thing as input output tables. Sometimes we do that, but we're looking for the patterns. And the reason I say we're looking for the patterns is if we figure out what the function is, we can find the pattern that is taking place. Okay, the pattern is the function. So this is also known as a pattern table. Looks a lot similar to what you've been doing so far. So what we're doing is we're trying to figure out what is the rule. So in your notebook, what I want you to do is just kind of draw out this table. Make sure you have the input, the function, and the output. And I also want you to think about what happens, what is the function when we go from smaller to bigger or from bigger to smaller. So take a second, put that into your notebook, and then we will continue on. Okay, I also needed to fix my output over here to make it correct, the function correct. So I paused for a minute just so that I could do that. So we go from smaller to bigger. When we go from a smaller number to a bigger number, the function is always going to be either addition or multiplication. Those are the two functions that go from smaller to bigger. When we go the other way, bigger to smaller, when the input is bigger than the output, then our function is going to be either subtraction or division in this case. So what we're doing is we're going, in this case, our input is smaller than our output, which means that we're getting to bigger numbers. So we are going to add or multiply. In order to figure out the rule, let's start with the easiest. Let's start with adding. 11 plus a number equals 25. 11 plus a number equals 25. Well, 11 plus 10 is 21. 22 to 3, 20. Oh, I had it right the first time. My math is off. 11 plus what equals 24? So I can say 11 plus 13 equals 24. Well, that's all good and well, but does this rule work for 15 to 28? So if I come down here, this rule has to be the same as this rule, has to be the same, has to be the same. So the rule goes throughout. So 15, if I add 13 to 15, will I get 28? Well, 15 plus 10 is 25, 26, 27, 28. That means 13 will equal 28. So my rule is plus 13. Always put plus, minus, multiply, divide, whatever the function is. Okay, you'll see I've got plus 13 plus 13. So if that's the case, then we can solve for r. So 18 plus what equals r? 18 plus 13. So 18, that's 28, 29, 30, 31. R would equal 31 in this case. So once you figure out the rule, it's easy to do the function. Well, I put in this number, I add 13, and I get this number. So now we're going to go ahead and we're going to attempt to put in another function table. Okay, so we now have our new function table up here. I paused for a moment just to change out the function table. So I'm going to input this number. I'm going to input 3, and I'm going to output 30. So I do something to the 3, and that makes it a 30. So I'm going from a smaller input to a bigger. And it might help if you put small input, bigger output, bigger input, smaller output. If that helps you to remember. So we are going from a smaller input to a bigger output. So I put 3 in, I do something to 3, and then I need to come out with 30. And then I put in 8, I do the same thing to 8, and I come up with 80. So let's try plus. 3 plus what equals 30? Well, 3 plus 27 equals 30. So 8 plus 27, does that equal 80? Nope, it equals 35. So that doesn't work. So we can't use the plus in this case. It will not be the plus 27. So since we tried the plus, let's try times. 3 times what equals 30? Well, if I do 3 times 10, I will get 30. Let's try times 10 here. 8 times 10, I get 80. Let's see if it works down here as well. 16 times 10 is 160. So if that's the case, then my function is going to be times 10. And if I solve for s, 10 times 10 equals, what does s equal? 100, because 10 times 10 is 100. All right, let's try a different function table. Okay, so our new function table that we're looking at now, we have an input of 18 and an output of 9. So my input is bigger than my output. So we're looking at subtraction and division. Okay, two different ways that you can do this. But 18 minus what equals 9? If I subtract 9 from 18, I will get 9. So I can try minus 9. And let's do 14 minus 9. If we 14 minus 9, do we get 7? We do not get 7. 14 minus 9 is not 7. So in that case, we are going to go ahead and say it's not subtraction. So if it's not subtraction, there's only one function left, and that's division. 18 divided by what equals 9? All right, if you are bad at division but you're good at multiplication, then you're actually good at division. You just have to do it the backwards way. So 9 times what equals 18? Well, that's a whole lot easier than 18 divided by what equals 9. But 9 times what equals 18? 9 times 2 equals 18, but remember that it has to be division. So 18 divided by 2 should equal 9. Remember, if you go this way and go backwards, you have to flip it. So 14 divided by what equals 7? Let's try 14 divided by 2. Well, 7 times 2 is 14, so 14 divided by 2 is 7. See if it works down here too. 8 divided by 2 equals 4. 4 times 2 is 8, so it works that way. So in that case, what would 12 divided by 2 equal? Well, our function is divided by 2, because that's the one we're doing. And since we're dividing by 2, 12 divided by 2 equals j. Solving for j, 12 divided by 2 should equal 6. So make sure that you can go forwards and backwards in this. If you want to start at the output because it's smaller on that side and go this way, feel free to do that. You can. Just remember that it's not times 2, that it's actually divided by 2. And I say that because if you go this way, yes, you're multiplying, but our actual function table goes this way, so you have to flip it. It's like when you're driving in reverse in the rear view mirror. You have to flip things, okay, so that you know which way that you need to go. These things flip, these things flip, okay? So it's actually division is your rule, not multiplication, but use multiplication to figure out what your division rule is.